Welcome to this class on similar triangles. Today we're going to explore similarity and similar triangles, and I'll make these concepts really easy for you. Let's start with a simple question. Take a look at these photographs. We have a stamp-sized photo, a passport-sized photo, and a larger photo. Are these photographs similar or not? That's what we'll explore in today's topic. Before we talk about similar figures, let's first understand congruent figures. Two geometrical figures having exactly the same shape and exactly the same size are called congruent figures. Let's look at these triangles. Are they congruent? To check if they're congruent, let's try to overlap them. If we rotate and move the yellow triangle, we can see it completely overlaps the blue triangle. They are exactly the same shape and size, which means these triangles are congruent. Now, let's talk about similar figures. Two geometrical figures that have exactly the same shape but not necessarily the same size are known as similar figures. Let's look at these triangles. Are they similar? These triangles don't overlap because they're of different sizes. However, if we scale the smaller triangle proportionally, we can see that they have the exact same shape. This means these triangles are similar as they have the same shape but different sizes. Let's compare some basic shapes to understand similarity and congruence. Here are three lines with different lengths. Can you tell which lines are congruent and which are similar? Lines AB and CD are both 5 centimeters long, so they are congruent. We use this symbol to show congruence. But what about similarity? All line segments have the same shape. They're straight lines. So lines AB and PQ are similar, and so are lines CD and PQ. We use this symbol to show similarity. Let's look at another example with triangles. Here are three triangles, ABC, PQR, and XYZ. Look at the measurements of their sides. First, let's determine which triangles are congruent. Since triangles ABC and PQR have all corresponding sides equal, they are congruent by the side-side-side criteria. AB equals PQ at 2 centimeters, BC equals QR at 3 centimeters, and AC equals PR at 4 centimeters. Now, are ABC and XYZ similar? If we compare the sides, we see that each side of XYZ is twice as long as the corresponding side of ABC. So ABC is similar to XYZ with a scale factor of 2. Let's move on to squares. Here are three squares with different sizes. Which ones are congruent and which ones are similar? The orange and purple squares both have sides of 5 centimeters, so they are congruent. They have the same shape and the same size. However, all squares have the same shape. They're squares. So all three squares are similar to each other. The green square has sides of 3 centimeters, while the others have sides of 5 centimeters. They are proportional but different sizes. Now, let's focus specifically on triangle similarity, which is our main topic. Two triangles are similar if and only if their corresponding angles are equal and their corresponding sides are in the same ratio. Let's look at an example. When checking if triangles are similar, we don't need to verify all 6 parts, the 3 angles, and 3 sides. There are 3 criteria we can use. Side, side, side. SSS corresponding sides are in the same ratio. Side, angle, side. SAS 2 sides are in the same ratio and the included angle is equal. Angle, angle. AA 2 angles are equal, which automatically makes the third angle equal too. Let's work through some examples to better understand these criteria. Here's our first example using the SSS criterion. In triangle ABC and triangle PQR, let's check if the corresponding sides are in the same ratio. Let's calculate the ratios of corresponding sides. AB divided by PQ equals 2.5 divided by 5, which is 1/2. BC divided by QR equals 3 divided by 6, which is also 1/2. AC divided by PR equals 4 divided by 8, which is 1/2. Since all ratios are the same, 1/2, the triangles are similar by the SSS criterion. We write triangle ABC is similar to triangle PRQ. Notice the order is important. We match corresponding vertices. Let's look at our second example using the SAS criterion. In the SAS criterion, we need 2 sides in the same ratio and the included angle to be equal. Here are triangles ABC and DEF. We'll check if they're similar using SAS. Let's check the conditions for SAS similarity. First, we see that angle BAC equals angle EDF. These are the included angles. Now, let's check the ratios of the sides that include this angle. AB divided by D equals 6 divided by 12, which is 1/2. AC divided by DF equals 8 divided by 16, which is also 1/2. Since the included angle is equal and the ratios of the sides are the same, the triangles are similar by the SAS criterion. Let's look at our third example using the angle-angle criterion. The AA criterion is particularly useful because we only need two angles to be equal. In these triangles, let's check if two corresponding angles are equal. Welcome to our lesson on triangles for Class 10 Mathematics. Today we'll learn about similarity in triangles, what exactly similarity means, and how we can identify similar triangles. Before we dive into similarity, let's recall some basics about triangles. In any triangle, the sum of all three interior angles is always 180 degrees. This is a fundamental property that will help us understand similarity. Let's start by comparing congruence and similarity. Two figures are congruent when they have the exact same shape and size. For example, all circles with the same radius are congruent, and all squares with the same side length are congruent. In triangles, congruence means that all angles and all sides are exactly equal. Now, let's understand what similarity means. Two figures are similar when they have the same shape, but possibly different sizes. For example, these triangles have the same shape but different sizes. For two triangles to be similar, they must have equal corresponding angles, and their corresponding sides must be in the same ratio. Let's look at this more mathematically. For these similar triangles, if the sides of the smaller triangle are x and the sides of the larger triangle are 2x, then the ratio of corresponding sides is consistent. Every pair of corresponding sides maintains the same ratio, which is 2:1 in this case, and all corresponding angles are equal. Now, let's learn about one of the most important theorems related to similarity, the Basic Proportionality Theorem, often called BPT or Thales Theorem. The Basic Proportionality Theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Let's look at an example to understand this better. In this example, we have a triangle ABC with a line DE parallel to BC. We know that BD is 2 centimeters and AD is 1.5 centimeters. We also know that CE is 1 centimeter. Using the Basic Proportionality Theorem, we can write that BD divided by AD equals CE divided by AE. This gives us 2 divided by 1.5 equals 1 divided by AE. Cross-multiplying, we get 2 times AE equals 1.5 times 1, which means AE equals 0.75 centimeters. Now, let's learn about the criteria for determining when two triangles are similar. There are several ways to prove that triangles are similar. The first is the AAA criterion. If all three angles of one triangle are equal to the corresponding angles of another triangle, then the triangles are similar. Since the sum of angles in any triangle is 180 degrees, if two angles are equal, the third will also be equal. So we also have the AA criterion. The SSS similarity criterion states that if the corresponding sides of two triangles are proportional, then the triangles are similar. Finally, the SAS similarity criterion states that if two sides of one triangle are proportional to two corresponding sides of another triangle, and the included angles are equal, then the triangles are similar. To summarize, we've learned that similar triangles have the same shape but possibly different sizes. They have equal corresponding angles, and their sides are in proportion. We can identify similar triangles using the AAA, AA, SSS, or SAS similarity criteria. The basic proportionality theorem helps us understand how parallel lines intersect the sides of triangles in proportional segments. Thank you for learning about triangle similarity with us.